Okay, so we've looked at frequency tables and frequency distributions. So the next thing to look at then is the kind of extension to that, which is a grouped frequency distribution. So a grouped frequency distribution is maybe slightly more categorical, I suppose, in nature. We are primarily using this even for larger and larger data sets where we maybe have a larger number or variety of data points, where it may not be reasonable or efficient for us to include every possible data point and look at the frequency of each. So instead, we consider categories or groups within which a number of data points will lie. And we kind of lay out these categories or these groups so that they're evenly spaced, so that they all cover maybe an even kind of range, and then we fill in those values. And I suppose a common one would be things like ages, would be quite a common one, where we might be grouping values together because it's maybe not as efficient for us to list people who are all exactly the same age, whereas we might get enough information for us to work with by considering certain age ranges instead. So when we're working with these group frequency distributions, we're generally going to have situations where like the groups are set up like I've listed here, 1 to 5, 5 to 10, 10 to 15, and they'll usually clarify as to where the 5 or the 10 or the 15, those boundaries are included. Typically the first one is included, but the last one is usually not, and then it would start the next group. That's typically the way that they're understood, but they'll generally put a note on the table just to clarify that, particularly if there's any change to that. So these are particularly useful, I suppose, for larger data sets where we would just want to kind of calculate the values within a range, but we obviously still want to be able to apply some statistics to that as well. We want to be able to calculate some of those values. And things like the mode, I suppose, we can work out a modal range, we can work out the modal group, we can't work out the exact modal value. Same with the median. We can say where the median would lie or what category it might be in or what group it might be in, but we can't give any exact value for what the median could be. And we actually have a similar issue, I suppose, with the mean, in that we can't even really get as far as calculating the mean when we're working with these categories. So what we have to do is to calculate mid-interval values. So we're looking at these intervals, these ranges that we've been given, these groups, and we calculate a kind of middle value, nearly like an average value or an estimate for these intervals. And as we move through our calculation for mean, we're going to use those estimates in place of the full group. So in a situation where we have, say, from 1 to 5, a mid-interval value for that group would probably be 3. Okay, so mid-interval value there would be 3. Or between 5 and 10, it could be 7, 7.5. Okay, between all of these values, we can get our kind of mid-interval values there, or results there. And these are useful for us because we are then going to use those and kind of calculate in the same way as we did with our frequency distributions. Now, it's important to just remember that all of this becomes then estimation because we've made an estimate for each individual interval. We've decided to just use the middle kind of average mean value as our calculation. And obviously, that is an assumption, that is, or not even an assumption, but it's very much an estimate, a generalization, and that I suppose does bring in potential error, or can kind of affect our results. So we'll use an exam question as an example. Here it's a 2018 Junior Cert exam question. The table shows the amount of money 30 students spend at the airport. We've again our intervals, as I said there, between 0 and 10, 10 and 20, 20 and 30. And you can see they've said like 5 to 10 means 5 or more, but less than 10. Okay, now that's not even one of the categories, but you can see what we mean there. So 0 to 10 includes 0, but doesn't include 10. 10 to 20 includes 10, but doesn't include 20. There's 30 students, and we know from our work on frequency tables that that should mean the bottom row there should add up to 30, and indeed it does. Okay, so we know that idea that the amount of money, we're never working as much with that, but the number of students is definitely something tangible. We're asked, first of all, what is the modal class? So the modal part just means mode, it's the one that's there the most. The modal class is between 0 and 10. So most students in this so most students here spent between 0 and €10 in the airport that day. So that's our modal class here. We're asked to use mid-interval values to estimate the mean amount of money spent, giving our answer in euro. So let's look at calculating that. The first thing we're going to have to do is to calculate those mid-interval values. The way that we do that is we calculate a value that's halfway between the two values we've been given. So say, for example, 0 and 10 here. I might add them together and divide by 2 to get 5. So a good mid-interval value there is 5. 10 and 20, the same thing. Add them together, divide by 2, we get 15. We get 25, we get 30, 35, we get 45, we get 55. So we can see that we're actually just going up in tens the whole time, which kind of makes sense because our intervals are also going up in tens there. So what we're going to be doing now is those green numbers I've written in, those mid-interval values, those are now our estimates for each of those categories. So we're now saying, for ease of our calculations, that everybody in the 10 to 20 range spent €15. That's kind of what we're doing to allow us to do some sort of calculation. So we're saying, let's go with 15. For the 30 to 40, we're saying, let's go with, say that they all were 35. And we are going to continue as if that's the case. So in the first case, we're saying that 9 people spent €5. 7 people spent €15. 8 people spent €25. And so on and so forth. So that's going to give me 610. We're going to divide that by how many people there were, which was 30, of course, and that gives me 20.333, which is approximately €20 and 33 cents. Okay, so we're looking at an average value, a mean value of around about €20 there. If we look at the values we have, that does seem reasonable. It's slightly upwards into the 20 value there. We might have even actually anticipated that it would be slightly lower than that, but it's just kind of slightly edging into the €20 category there. And actually, no, that seems like quite a reasonable place for it to be. I was looking at the wrong one there. That seems like quite a reasonable spot for it to be. So we've just taken those mid-interval values and multiplied that value by the frequency of each of those intervals. And I suppose that just allows us to do any calculation at all. Otherwise, there would be no calculation we could do. Part C says estimate the median amount. Now the median is the middle value when they're in order of size. There are 30 different students here. So the middle student is going to be between the 15th and 16th student. Okay, so the middle student is between the 15th and the 16th student. So we're going to go through again like we did before and calculate what interval they're going to appear in, and by just doing 2 intervals we have accounted for 16 students. So we are looking at the 15th, both the 15th and the 16th student are between €10 and €20. Okay, now in terms of actually estimating the median, so we can say the median is in this range. If we want to go further, as they've asked here, to estimate, we have a few different options. We could say 15, which is our mid-interval value, which is kind of an average value for that interval. We could say, well, 15 and 16 would be nearly the last values in that data set, or in that interval, I should say. So they might be closer to the higher end of those values. So we could say 18, we could say 19, we could even say 1850. Any value there really that you can justify would work absolutely well. And really there's no way of being sure beyond the fact that it's in that range, because they haven't given us any more information. So let's look at another question or two then under our grouped frequency tables here. So I think I have 2 questions here. So a class of 25 students were surveyed to find out how many WhatsApp messages they each sent in a particular week. The results are shown in the table below. A student is picked at random. Find the probability the student sent 50 or more messages. So 50 or more, well, we're starting with the 10 people here and all the way up to the very top there. So we have 22 total people that we're considering, and that's out of 25. So actually quite a large portion of students there who were included, and that doesn't simplify down at all. Okay, so 22 over 25. A student is picked at random from those who sent 50 or more message. Find the probability that this student sent 50 to 70 messages. So if we're only picking out of the people who sent 50 or more, that's out of 22, and we want to know the probability that they sent 50 to 70. So that was 10 people out of the 22, which is 5 out of 11. Using mid-interval values, we're asked to calculate the mean number of messages. So to find my mid-interval values, I need the values that are halfway between these boundaries on the intervals. So we can add them together and divide by 2. So that's 15. Here it's 80 divided by 2, that's 40. 50 and 70, that's 120 divided by 2, that's going to be 60. 70 and 100, 170 divided that by 2 is going to be 85. Brain stopped working. And 260, that's going to be 130. Okay, my brain not fully working with me there for all of those, but we got there eventually. So I suppose the issue here with these intervals, and I suppose what's kind of affecting our mid-interval values a little bit, that the intervals actually aren't even here, which is kind of unusual for us to see in some of these questions. So we're estimating the mean number of messages, so we take our mid-interval value and we multiply it by how many students we're estimating received that number of messages. So 60 by 10 plus 85 by 7, 130 by 5. Okay, so let's work out these. So 15 plus 80 plus 600 plus 85 by 7. Okay, I'm going to have to use my calculator for that one. 595 and 130 by 5 is 650. Let's add all of those now and get our total. So 15, 80, 600, 595, 650 is 1940. Divide that by how many students there were, which was 25. And we can calculate the mean number of messages sent per student, which is 77.6. We look at the values we have, we were maybe expecting something within that range, because that does seem to be where the vast majority of the messages lie, or the frequencies lie. The students found the total number of WhatsApp messages they sent in this week. We're asked to use the data in the table to find the smallest value this total could be. The total number of WhatsApp messages they sent in this week. So let me see. They were surveyed to find out how many they sent each week. The results are shown. So we're asked the smallest value this total could be. Well, the smallest value that this total could be would mean making these intervals as small as possible. Okay, if we want the total number of messages sent to be as small as possible, we want in each of these intervals for the students to have sent the smallest number they could to still be within that interval. So what I mean here is in the first interval, we actually want this person to have sent only 0 messages, this person to have sent only 2, this person to have sent only 50, and so on and so forth. If we can keep it that each of these categories they only sent the smallest number of messages possible, then that's going to give us the smallest total overall. So multiplying each of those by the smallest number, or multiplying each of those number of students by the smallest possible number of messages and summing those to get our overall total. Those questions where they're looking for you to work with the intervals, those can be a little tricky and just require a little bit of thought behind them there. Let's quickly fly through one more. So the 2013, we need to use the data to complete the grouped frequency table below. So we're given a lot of information here, a lot of different data points or different numbers here. So we need to kind of plot them in. So The best way we can maybe do this, and I'm going to do it above, is I'm going to do a little bit of a tally for myself just to try and keep an eye on everything. So I'm starting with 22,000. Each of these salaries is given in thousands. So that's my 22,000 there. 1650, 38, 26.5, 15, 21, 1550, 46, 42, and so on and so forth until we've included every possible one we can. It's just a little bit of just, what should we do this here? I probably could have had this done ahead of time. This would be the moment for the, here's one I prepared earlier, 2450, but it's no harm to just follow the method as well. 52, 33. You can see I'm marking them off as I go as well, because I don't want to accidentally forget one if I can at all avoid it. And we may still, okay, but we'll do what we can. It's actually another one here, 25, 33, 20, 1950, and 1600. So let's see, we have 1 here, we have 6 here, we have 12 here, we have 9 here, 2 here, 1 and 1, and let's try and add these together. 1, 1, 4, 13, 25, and 7 is 32. 1, 2, 3, 4, 5, 6, 7, 8 times 4, 32. Lovely. Okay, so we've got them all. We're asked to use mid-interval values to find the mean salary of the employees. So let's fill out our mid-interval values. For 0 to 10, that's going to be 5. This is going to be 15. This is going to be 25. This is going to be 35, 45, 55, and 65. So we are doing 5 times 1 plus 15 times 6 plus 25 times 12 plus 35 times 9 plus 45 times 2 plus 55 times 1 plus 65 times 1. So that's going to give me 5 plus 15 times 6 is 90 plus 25 times 12, we've got some big numbers here, is 300. 35 times 9 is 315. 45 times 2, of course, is 90. 55 times 1 is just 55, and 65 times 1 is 65. Let's add all of those together. Sorry, I keep swiping over, but it's all changed. 5 plus 90 plus 300 plus 315 plus 90 plus 55 plus 65. Got them all. Yeah. Is 920. We need to divide by how many there were, which we worked out was 32. And again, last one with the calculator here, hopefully, is 28.75 as a mean value there. So mean salary 28.75, which converting that to thousands is 28,750. Okay, and that seems like, again, a reasonable enough answer. We're kind of within that middle ground, slightly to the lower end, maybe to account for the fact that there's more data points to that side than there maybe is to the upper side. Outline another method which could have been used to calculate the mean salary. I'm just going to say we could have used the original salary values. We could have taken the values that were presented to us before we created our table, so all these original values at the top, and we could have used the original salary values, add and divide by 32. They're asking which is more accurate, so hopefully from our introduction there we're all clear, but which would be more accurate would be to use the original values. And the reason for that would be mid-interval values are estimates. Those are estimated values. Those are our kind of estimates for each of those intervals. We're kind of making an educated or a helpful guess, I suppose, that the value that's within there is kind of an average value for that interval, when in fact that may not be the case. And so, of course, using the original values is always going to be much more accurate than that. So really with a grouped frequency table, the only difference that comes in is the fact that the data is presented in these grouped intervals, or classes or range of values there, as opposed to just having the individual values. And that brings in the question or the use of those mid-interval values if we're calculating the mean. Mode and median kind of follow the same as normal, and we just have maybe some added little questions that can come in as part of it then.